my name is Cinta, and this is my part. I will explain the definition. Normality test is a statistical procedure used to determine whether a dataset or residuals from a regression model follow a normal distribution. In the context of multiple linear regression, the normality test specially examines whether the residuals errors are normally distributed, which is one of the key assumptions that must be met for the validity of regression analysis. A commonly used method to determine whether a model is normally distributed or not is by examining the residual histogram to see whether it forms a bell-shaped curve. However, this approach can be misleading as deciding whether the data are normally distributed solely based on visual observation can lead to incorrect conclusions. An alternative way to determine normality is by using the skewness ratio and kurtosis ratio. These ratios can serve as indicators of whether the data follow a normal distribution. Skewness ratio, skewness value, or standard error of skewness. Kurtosis ratio, kurtosis value, or standard error of kurtosis. Decision criterion as a general guideline if both the skewness ratio and kurtosis ratio fall within the range of -2 to +2. The data distribution can be considered normal. Santoso, 2053. The normality assumption is crucial for validity of hypothesis test, F-test and F-test, T-test and F-test, accuracy of confidence intervals, reliability of prediction intervals, and overall model inference.
I'm going to read the steps of the analysis. First step, we have perform regression analysis. Number 1, open SPSS and load your dataset containing chicken consumption per capita data. Number 2, go to analyze, regression, and then linear. Number 3, enter the Y variable, chicken consumption per capita, into the dependent box. And then number 4, enter the independent variables, which is x3, x4, x5, into the independence box. Next, we have step 2, save unstandardized residuals. First, we click the Save button in the linear regression dialog box. 2. In the Save dialog, check the unstandardized option under the residual section. Number 3, we click Continue to return to the main dialog. Number 4, click OK to run the regression analysis. Number 5, SPSS will generate a new variable named unstandardized residuals, or res_1 in your dataset. Step 3, we have generate descriptive statistics for residuals. First, go to Analyze, Descriptive Statistics, and then we go Descriptives. Number 2, select the unstandardized residuals, which is res_1 variable from the left box. Number 3, move it to the variables box using the arrow button. Step 4, request skewness and kurtosis statistics. First, number 1, we click the Options button in the Descriptive dialog. And then number 2, we check the kurtosis and skewness options. Number 3, we click Continue to return to the main dialog. Number 4, we click OK to generate the output. And the last step, we have step 5, which is calculate ratios and interpret results. First, we extract the skewness value and its standard error from the output. Second, calculate the skewness ratio, skewness/STD error of skewness. Third, extract the kurtosis value and its standard error from the output. Fourth, calculate the kurtosis ratio equal kurtosis slash STD error of kurtosis. And lastly, fifth, compare both ratios against the criterion range of 2 min minus 2 to plus 2.
Hello, Assalamu alaikum. Let's continue with the calculation results based on the example question. Okay, so in this slide, we can see the calculation results based on the example question. This part showed the descriptive statistics output that we obtained from SPSS. The focus here is on the understandardized residuals. Basically, these are the difference between the actual data values and the predicted ones from our regression model. Understanding these values help us check if our model meets the assumption needed for regression, especially the assumption of the normality. Let's go to the next slide. Residual statistics table. From this table, we can see that the minimum residual is minus 48.68 and the maximum is 31.49. This range shows how far our prediction deviates from the actual values. The mean residual is exactly 0.000, which is a good sign because it means the errors are balanced. The model is not overestimating and underestimating overall. The standard deviation is 19.88, showing how spread out the residuals are, and the total number of data points used here is 23. Overall, these results indicate that our model's residuals are constant and centered around 0. Let's go to the next slide. Descriptive statistics for normality assessment. On this slide, we can see the descriptive statistics for assessing normality. The skewness value is minus 0.568, which means the data is slightly skewed to the left, but is still within an acceptable range, generally between minus 1 and plus 1. The kurtosis value is 0.274, which is close to 0, suggesting the shape of the distribution is quite normal, not too big and not too flat. So from these two indicators, we can conclude that the residuals are approximately normally distributed. This confirms that our regression model meets the normality assumption, which is very important for accurate statistical inference. Thank you.
Right now we have calculation of skewness ratio and kurtosis ratio. Skewness ratio calculation is skewness divided STD dot error of skewness. For example, it's like minus 0.56 h divided 0.4 h1 equals minus 1.1 h1, and then for kurtosis ratio calculation, 0.274 divided 0.935 equals 0.093. And then for summary of result, we have measure. The measure is skewness statistic minus 0.56 h, and for STD error, we have 0.4 h1, and then for the ratio it's minus 1.1 h1, and then for criterion minus 2 to plus 2, and then for stats normal, and then for kurtosis statistics is 0.274, STD dot error 0.935, for ratio 0.293, and then criterion minus 2 to plus 2, and then it's normal.
Okay, next slide. I will explain the interpretation of result and conclusion, specifically the interpretation of the skewness ratio. From the calculation, the obtained skewness ratio is minus 1.181. This value falls within the acceptable range of minus 2 to plus 2. The negative value indicates that the data distribution is slightly left skewed, meaning the tail extends towards the negative side. However, since the magnitude is only minus 1.181, the skewness is quite small and remains within acceptable limits. This suggests only a minimal deviation from perfect symmetry. Therefore, this level of skewness does not violate the normality assumption, and the data can be considered approximately normal for further statistical analysis. Next slide. I will explain the section titled Interpretation of Results and Conclusion from our research. First, interpretation of kurtosis ratio. First, from the kurtosis ratio analysis, we obtain a value of 0.293, which fall within the acceptable range of -2 to +2. This positive value indicates that the distribution has slightly heavier tails than a perfect normal distribution. However, since the value is very close to 0, it means the distribution is nearly normal. Therefore, the kurtosis value does not violate the normality assumption. Second, additional supporting evidence. Next, let's look at some additional supporting evidence. The mean of residuals is 0.0000, which perfectly meets the requirement that residuals should have a mean of 0. The residual range from -48.6 from -48.68433 to 31.48967 show a reasonable symmetric distribution around 0. The standard deviation of 90.8859 indicate consistent variability. There are no extreme outliers since all standard residual fall within a +3 standard deviation. All of these findings confirm that the residuals are normally and consistently distributed. The last is conclusion. Based on the skewness bracket -1.181 and kurtosis bracket 0.293 values, both of which fall within the acceptable range, we can conclude that the data distribution is normal. This means the normality assumption is satisfied. The t-test for individual coefficients and the f-test for overall significance are valid. The confidence intervals are reliable. The confidence intervals are reliable and accurately reflect the uncertainty in the estimate. The regression model can be used for prediction with strong statistical confidence. Furthermore, the conclusion drawn from the regression analysis regarding the relationship between chicken consumption per capita and the independent variable x3, x4, x5 and real pair are statistically sound. And the last, overall assessment. Lastly, the overall assessment shows that the regression model meets all its fundamental assumptions. The performance indicators are very strong. R equals 0.933, adjust R equals 0 0.930 and F equals F F equals 73.871 with P 0.001. This confirms the reliability of the model used in this analysis. Therefore, the residuals are normally distributed, confirming the validity of the regression model for analyzing and predicting consumption per capita. And the last, in conclusion, kok ada lagi ya? Ini juga baru pulang kok. In conclusion, all the statistical assumptions are met. The model performs well, and it can be confidently used for further prediction and analysis. Thank you.